Thank you very much for having me. I feel super special, scared, and privileged to speak here tonight. So, firstly, let's address the elephant in the room, my accent. So, I'm from South Africa. Me and my family, oh, another one. My family and I are from South Africa. We immigrated to Australia a few years ago and experienced the bushfires in New South Wales, the floods, and the epidemic. Apart from that, we absolutely love Australia and are excited to contribute to the community. I started my career in software development late in life. So my husband is a software engineer like since forever, and has been my inspiration and motivation to pursue this career. So I really enjoy front and back end development for roughly 9 years now. Today, I'm proud to be working for Azenix, part of the Mantle Group, the winner of Australia's Best Workplaces. Mantle Group is a technology consultancy firm with 9 different branches, each dedicated to their specific technology. At Azenix, the A team, we specialize in software and cloud and data engineering within the Microsoft ecosystem. So if you're thinking about a change or just moving around a little bit, just chat to us and we'll see what we can do. So I had the privilege to work on a project where we used Blazor. Blazor, interestingly enough, not a lot of people know what Blazor is. Tonight's session is inspired by them. And I'm not an expert, but I just thoroughly enjoy the tech stack and want to show you the kind of fun that you can have with it. And hopefully it will clarify some of the unknowns and maybe it will inspire you to get playing with it too. So first, trivia fact. Blazor is made up of 2 words, browser and razor. It was Steve Sanderson's personal project, the knockout guy. He showed it off at NDC Oslo in 2017. The first version was built on .NET Anywhere, and Microsoft loved it so much that they adopted it, rewrote it from scratch, replacing .NET Anywhere with the Mono runtime. The ASP.NET team includes Steve, and he has very insightful blogs and talks about the subject. I highly recommend that you check him out. So Blazor is a framework. It gives us all the benefits of a modern, rich, single-page application using .NET end-to-end. It consists of HTML, CSS, C#, and Razor. So let's dive into Razor. Razor is a template engine, and it consists of views and pages. The Razor syntax combines C# and HTML. An MVC project, it powered the views and still has. Am I on the right screen? Yeah, I was just thinking what. Yeah, it has a .cs HTML file extension, and in Blazor, it's a .razor file. And interestingly, it is formally referred to as a Razor component and informally as a Blazor component. And this is an example of a Razor page. So notice about the 5th line, the @ sign prefixes the C# code. Blazor has 2 hosting options, server and browser. So let's discuss Blazor server. Updates on the UI are handled over a SignalR connection. The server executes the C# code. It handles the JavaScript interop calls, and the UI updates are applied to rendered components. All this processing is happening on the server. So if your server is down, your website's going to be down too. Let's discuss Blazor running on WebAssembly. So firstly, what is WebAssembly? Well, it's an instruction set formatted in a compact bytecode. That's an example. It runs on a stack-based virtual machine in a memory-safe sandbox environment. So if you tilt your head ever so slightly, it looks like the Matrix, right? Blazor is supported on modern web browsers without any plugins. We have access to the full functionality on the browser using JavaScript. It uses the Mono runtime that evaluates .NET assemblies. It offers different compilers, and depending on which one is used, it will either translate or compile our code. So let's dive into this translation and compiling of our code. So JavaScript is an interpreted language and does not get compiled like C#. An interpreter on the browser reads the JavaScript code and interprets each line, executing it line by line. In interpreted mode, the Mono runtime is compiled to WebAssembly, which can then be loaded and executed by the browser. Our standard .NET DLL files can also be loaded and executed by the Mono runtime. Interpreted mode is the quickest in terms of development speed, as reloading application DLLs is very quick. If we switch our app to run in ahead of time mode, our DLL files are compiled to WebAssembly directly. Compiling our code in WebAssembly takes a while, and part of the Mono runtime is also loaded by the browser to handle low-level operations like garbage collection. But essentially, the application is executed as regular WebAssembly. The size of the application being downloaded is huge, and so it takes a while to download. But once it's downloaded, the performance is really quick. So ahead of time mode is obviously the best for production. So to enable AOT mode, ensure that you have the WebAssembly build tools installed by running that command. Add the run AOT compilation property to the app's project file, and the compilation will only be performed once the project is published with the release configuration. In .NET 7, they have improved the AOT compiler, which is exciting, and now we even have the SIMD configuration as well for those with a heavy compute apps and image manipulation. That will be a good go. So I have developed a simplistic game in Blazor to show you how easy it is and also to discuss some of the interesting things about it. So let's have a look. The purpose of the game is to collect as many flags while avoid being caught by the black holes. I am moving the rocket in the video using the up and down, left and right keys on the keyboard. Notice how the moving flashing icons, the black holes, are moving in on the rocket, getting closer with every step. My son is 14 years old and he writes games in Unity and constantly tells me that I need to move the rocket faster and increase my refresh rate. But if anyone knows of a meetup or a group he can join with like-minded people, please let me know. This game is not written in Unity, surprise. It's just Blazor with CSS, HTML, C# and a little bit of JavaScript. I'm sure by now you've noticed that when I capture a flag, it disappears from the top screen and jumps to the bottom screen and it's twirling with in color. And when the black hole captures the rocket, it merges with a giant black hole. And when everything is discovered, you are rewarded with a Star Wars experience. I was going to do a live coding session, but I realized that I cannot type nearly as fast and my nerves are not going to do me any justice. So I will share the GitHub repo link after the session. The game is developed in Blazor WebAssembly, and Rider is my preferred IDE. I will create a new project applying the space code theme in the code. So let's get started. When creating a new Blazor WebAssembly project, the base template creates an application with examples of navigation, the counter button where you can click and it increases the count, and the weather API call. In .NET 7, we have an empty Blazor template. Woohoo! So this will not be necessary to go up and clean it out every time. At this point, I'm just illustrating clearing up information that's not required for the game. For example, the CSS libraries, the styling, and sample data. But there are a couple of interesting things I'd like to point out in this index.html file. There are some of the links to the bootstrap that I need to clear out. The app.css file needs to stay because there is some styling that's used in the app. And then the interesting part is the link reference to the project.styles.css file. In my case, it's called intro.blazor.css.styles. That enables CSS isolation, which is the component-specific style. So what does that mean? When creating a CSS file with the exact same name and case as the Razor component, you will notice that when it's created, it is a little bit indented, like it's a subset of the Razor file. Blazor will therefore render the component style from that CSS file only for that component. These styles are component-specific styles. So let's jump back into the index.html file. There is a div with an ID set to app, and we have a div to show any errors if there was any. And notice the script line where we've got the underscore blazor.webassembly.js file. So that line is going to start Blazor once the document is ready. If this was a Blazor server app, it will reference the blazor.server.js file. In the program.cs file, there's nothing to note that's Blazor specific really. It's just builds the host for the Blazor application and get a collection of components to add it to the Blazor application. The app.razor file is a little bit more interesting. It contains the router information. So the router component enables routing to the Razor components in the app. When a Razor component with an add page directive is compiled, the generated component class has route attributes that specifies the component's route template. At runtime, the run view component receives this route data from the router and renders the component with its layout. This means we don't have to import components like you have to with your JavaScript frameworks. The Blazor project template created the main layout component as the default component. So let's jump over to the main layout file. Looking at the main layout file, the layout component base is inherited. It is an optional base class for components that represents a layout. It defines a body property for the rendered, there we go. It defines a body property for the rendered content inside the layout. The navigation and different sections which are laid out in the installed template is not required for the game. So I'm just clearing that out, and now we're ready to start with the game. This is not an exciting slide. I'm just creating a model which is needed for my astronomical objects. It's a base class, and then all of my other models are just going to implement these base class, and some of them extending it with specific properties that's going to be required for them. You'll see the rocket. I will have a status, a direction it's moving, and the stars. I just wanted to say maybe that happened already. We have the stars, and that just needs an image and whether it's been discovered or not. Some information about the viewport is required to create the game. That means JavaScript to the rescue. We need the positions of the stars and the black holes, the dimensions of the universe, and setting focus to the rocket without having to click on it every time. This information will be sent down to centers for further processing. This info can easily be gathered using element function called getBoundingClientRect in JavaScript. I'm sure that's like rectangle or something. It returns the position of the element relevant to the viewport, which is really nice. So all I'm doing is I'm building up an object which can be casted into an astronomical object. This logic is required for the rocket position, stars, and the black holes. So just take note of that function name because you're gonna see it just now. To call JavaScript from Blazor, we can use the IJS runtime, which is registered by the Blazor framework. You just inject the IJS runtime abstraction and call the method invoke async and pass it the JavaScript function name. I wasn't done. I wanted to say that they've done so much work with the IJS runtime. In .NET 7, it's really exciting because now we can call directly from .NET apps into JavaScript without having the Blazor framework. I think this is going places. So the Orion Nebula is a place where stars are born. Even though technically speaking, black holes are dead stars, I decided that for the purpose of this game, they will be born here too. Nebula is a cool name, and so I named the centers where the stars and the black holes are populated, the nebula center. Links to the sources of the icons is updated in the index.html file, and I'm using Font Awesome and Dev Icons. Super exciting. The centers are not Blazor specific, but I'm just going to explain them quickly. The logic in these centers, illustrating how everything fits together and so that it makes sense to you. In the nebula class, the black hole method receives the galaxy scale. Each black hole property is then populated. Notice for each black hole, the top and left properties are calculated relevant to the galaxy scale. And I'm referencing the font awesome icon type and the animation and color. The star birth method also requires the galaxy scale. Here is my algorithm calculating the position for the stars relevant to the galaxy. It is to scatter them each time in a different place when the page is loaded. The biggest challenge was to get them not to overlap. Sometimes I'm lucky with this algorithm and sometimes just not at all. So dev icons is used as a source for the stars icon, and the scorecard requires the colored version, which is an image on dev icons, and that's why I have that additional property there. Okay. The observation center receives transmissions from the satellite service and then updates the components with its finding. These findings includes new discoveries that the rocket has made, icons that needs to still be discovered, whether any black holes collided with the rocket, and the dimensions of the universe. The satellite service is then injected into the observation center. The observation center studies this information supplied by the service, and it will be able to conclude the following: the universe dimension, whether anything was discovered, if the black holes caught up with the rocket, and what the status of the game is. The control center's purpose is to move the objects on the screen. The move black holes method moves the black holes relative to the rocket's position. The number 7 is the number of pixels the black hole is moving. So by increasing and decreasing that number will make it easier and tougher to catch up with the rocket. The move rocket method gets the rocket position by calling the satellite service. It receives the keyboard events, which is the key that was pressed on the keyboard, and the switch statement makes it very easy to specify what needs to be done when that specific key was pressed. So you'll notice that the number 20, which is the number of pixels the rocket moves every time, again, that can be changed and will make it slower and faster as you wish. The direction of the rocket is also set in the switch statement. Blazor has dependency injection built in. All the centers and satellite services needs to be registered in the program.cs file and can be injected into the Razor components. Galaxy is a page. It's a Razor page. Looking at the path of the URL, it is set to root. The page has two main components, the universe and the scorecard. The universe contains child components, which is the rocket, list of black holes, and a list of stars. And the scorecard contains a list of stars. In Pages directory, you'll find the galaxy.razor file. The add page directive shows the URL pattern in this case, it is set to root. The add injective is just injecting the dependency injection into the Razor page. And some components are shown depending on the rocket status. Take note that the status lost and status win components are outside the Galaxy component. And the C# code directive is where the C# code is defined. Looking at the C# code, we've got properties that are initialized. We've got the galaxy scale, the constellation, which is a group of stars, and letter. I'm sure you're thinking, wait, what, litter? I'm not making that up. I did my research. That is what you call a group of black holes. You don't believe me? Well, Dennis Overby from the New York Times did his research. He did serious investigation and is, and is doing some serious name dropping, like quoting people like Stephen Hawking. He concluded that black holes are like kittens. They do not pose a threat to us in their current incarnation, at least for now, and are a delight to watch in the distance. So that's it. I'm therefore convinced this is what we're going to call my group of black holes is a litter. So let's continue with the galaxy.razor page. On after render async is one of many Blazor lifecycle events. Razor component lifecycle events can be processed in a set of synchronous and asynchronous lifecycle methods. These methods can be overwritten to perform additional operations in components during component initialization and rendering. So firstly, we have the first thing that happens is the set parameters async. Once the component is initialized, it triggers off the onInitialized lifecycle method. OnParameter set is called when the parent component is re-rendered. That means when the rocket position changes, the litter must be updated to move closer to the rocket. OnAfter is then triggered. At this point, the canvas is no longer, so when you start up the app, it's a blank canvas. When OnAfter render is triggered, in this case, the canvas will no longer be blank. The defs will be rendered and the screen will be drawn, which is a perfect case to then overwrite this code and then apply any other additional logic. State has changed notifies that the component was changed and needs to re-render, and event callbacks automatically call state has changed. So by overriding the on-after async method, I can get the universe scale and give birth to the black holes and stars. The galaxy will not exist if the rocket status is 1 or lost, and the method will then just exit in that scenario. The galaxy property is updated with the universe scale by calling the observation center. As I'm sure you can imagine that we don't want to populate those objects over and over, I'm using the first render check. That top little red square is not supposed to be there. And it's populating those properties with the values. Rocket position has a position of absolute CSS setting. So as a result, I'm setting the position to centralize it on the screen. We have calling state has changed so that the rest of the components can then re-render and draw itself again. On rocket moving is an event callback. When a key press is registered in the universe component, which is a child component, this method will be called. It will move the rocket, detect new discoveries, check for any discovery statuses to be set, move the black holes, and detect any collisions. Being an event callback, it will call state has changed automatically. All these components will then be re-rendered. The universe component has a couple of parameters that are passed down. The event callback, we have black holes, constellation, and rocket. So let's have a look at the universe component. So just zooming in there. Notice there's no page directive at the top of the file. We only have the control center which is being injected. Looking at the HTML file, we can clearly see the div, the rocket div, and the styling, which is referencing properties in the C# code. On key down is an event on the div that will get triggered every time the key is pressed on the keyboard. It will then call the on rocket moving method. The parent component galaxy is on the left of the screen, and then we've got the universe on the right-hand side. Notice the parameter settings above the properties in the child component. This indicates the properties values are received from the parent, and the names needs to be the exact same in the parent component passing down the information, else you'll get an error you'll quickly see. On parameter set in the universe component is triggered when the properties are updated from the parent. It sets the rocket position. After the rocket position is updated, focus needs to be set, and that's why I'm doing that in the on-after render async call. This is a view of the litter component, which is a child of the universe component. It receives a litter information from the parent, and the HTML just loops over that information, drawing it on the screen. The same thing is happening for the constellation, which is the list of stars. It receives the information from the parent, and we then draw that information on the screen. The scorecard is a little bit different because it has the discovery, which is the image, and then the icons on the screen. So I just have a bit of a bigger HTML section there receiving the information. And then we have the win and loss components. They don't receive any information from the Galaxy parent component. It only contains divs needed for CSS rendering. And that's it. That's how easy it is to create a game. Thank you so much. I hope you found the session informative. There's my GitHub repo. It's published as a geostatic web app. And any questions? Okay.